Hey you guys, I hope y'all are enjoying your Sunday afternoon. Thought we would do a little experiment this afternoon and maybe a little math problem to go along with it. How's that sound? All right, so I got one of these heat solution reusable instant hand warmers. I think most of you have seen these before in my classroom, maybe even seen what it does, but I thought we could try it out. We can see if we can calculate how much heat is released by the hand warmer. And while we're at it, why not write the equation for what's going on and draw an energy diagram? So before you can try to solve this problem, we need to know some things, right? Let's see. We need to know the heat capacity of the sodium acetate that's in here. We need to know what this is and how much of it we have. So this is a supersaturated solution of sodium acetate. And sodium acetate, I'm sure you all remember, sodium and acetate. I looked this up. A supersaturated solution of sodium acetate is 77.8% by mass. Sodium acetate, the rest would be water. So I recorded the mass of this and estimated for the plastic bag, but we should be pretty close, that there should be about 72.6 grams of sodium acetate dissolved in here. And I also looked up the heat capacity for sodium acetate and found that it was 3.0 joules per gram degrees Celsius. So before we can calculate the heat released by the process, we need to know, well, you might not have seen this, so let me just show you what happens too. But we need to know the temperature change, the initial and the final, and the mass. I just showed you guys. We're going to use this for our mass and this for our heat capacity. And let's measure what the temperature change is. So let's see. So these heat solution hand warmers have a little metal disc inside there. Let me switch over. Let's see what our initial temperature is and hit start. Go to logger. I've got our temperature probe plugged in. Come on. Let me see. How's this? Can put it all on one page together. Maybe not. All right, so we're starting at 23.3. I'll go ahead and hit start and then toggle back over to our video. All right, so when we crack the disc, that gives it a little crystallization point, and all of that solution starts turning into a solid, and it gets hotter and hotter. I'm just going to wrap this up with our thermometer, and we can watch this go up and up and up. Let's see where we max out here. All right, so we're at 36, 37, 38. I can feel it warm in my hand, so clearly not a perfectly insulated system. I just wrapped my little Rocket Notes cleaning cloth around it to try to keep the heat in. We're at 45 degrees Celsius. 46. And we're starting to level off. Oh, still climbing. 50. 1. I'm doing right now. 51.5 degrees. Where are we going to level out, you guys? 52. Still going up. 52.4. All right, we've pretty well leveled out. We'll let that go for another minute. See where we end up. Okay, 52.4. All right, I think we can probably call that our stopping point. What do you think? We'll stop there. Switch back to our work. Take a look. All right, so you have the data that you need to solve this. 52.4 degrees Celsius. My initial temperature was, what was our initial temperature? Who remembers? Not me. What is it? So we started at 23.3. Okay. Why don't you pause and calculate and see what you get. So let's report our answer two ways. So let's calculate the joules of heat given off. Let's also look at joules per gram of heat released. Draw an energy diagram and describe it. And then I'll write the reaction with you. So let's do this other part together. So this is sodium acetate. And when we started off, it was clear liquid, right? It was aqueous. Not very much water in there, supersaturated solution. To make a supersaturated solution, you dissolve as much as you can, and then you boil it, and then it'll hold just a little bit more, but it's unstable. And so any disturbance, if you drop it on the floor, sometimes that will be enough to trigger crystallization and trigger the formation of the solid. So when we disturbed it by clicking the metal disc, we watched it convert into sodium acetate. Solid. And we couldn't see the water when it's in its solid form. It just looks like it's all white crystals, but the water molecules are just in between the solid crystals. All right, so let's give you a minute to pause and calculate, and then come back and check your answer. All right, so when I plugged in the numbers here, the mass, the specific heat capacity of sodium acetate, and my delta T, my final minus the initial temperature, got 6,337.98 joules. We should have three significant figures because our measured number was 72.6 grams of sodium acetate, and we also knew our temperature to three significant figures. So rounding that off to three significant figures gives me 6,340 joules. When I change that into joules per gram, that would just be dividing by, so joules per gram of heat released, dividing by my total grams of sample, and that tells me that for every 1 gram of sodium acetate, 87.3 joules of heat are released. For part C there, draw the energy diagram and describe what's happening. I'm sure you already drew yours. Right. Energy increasing. So if I put my reactants here, my aqueous sodium acetate, I draw one hump, my products at a lower energy, right? That would give me, it's my delta H, a negative delta H, and to describe it, I would say that this is an exothermic process. You have to draw your products lower in energy than your reactants because heat was released to the surroundings. And so it feels hot and we give off heat from the system to the surroundings. Here's what it looks like now that it's all solid. Still hot, still holding at 52.4-ish degrees, somewhere in that range. All crystalline solid. The way that we recharge this is to boil it. Boil it for several minutes and start that up again. All right, hope you had fun doing a little Sunday afternoon math problem. Tomorrow we are going to start new things.